In this video, we're going to look at graphing quadratics that are given to us in standard form. Always in the past, when we have been given something in this form, if we wanted to find the maximum or the minimum value, we had to use our calculator. So what we're going to focus on today is being able to find that maximum or minimum without the use of the calculator. Well, first we need to determine if we're going to have a maximum or a minimum, and then we'll look at how to find the point. So first of all, looking at this, I know it's a quadratic. I have a highest exponent of 2, and the number here in front of the x squared, that's that understood 1. My a value will be 1. 1 is greater than 0. So what does that mean for my graph? Does it open up or down? It's going to open up. And remember, when the parabolas open up, that means that it's going on and on forever up. Well, if this is the shape, then my vertex that's down here, is that going to be a maximum or a minimum? That's going to end up being a minimum value. It's at the bottom of the parabola. All right, well, how about this one over here? This time, again, I can tell it's a quadratic because I have a highest exponent of 2. My a value right here is a -1. -1 is less than 0. So if positive meant that it opened up, what's going to be true for it when it's a negative? It's going to open down. So remember, when it opens down, it looks like this. So the vertex that's up here, is that a maximum or a minimum? Well, it's up at the top. This one goes on and on forever down, so that is going to be a maximum. Okay, now let's consider how to find the coordinates of that point. First of all, remember, when something is written in standard form, it's like this: ax squared plus bx plus c. The a always is on the square term, the b is always on x to the first, and the c is always the constant term with no x. So if this is out of order, for example, if the x squared term was written over here for some reason, first thing you would want to do is rearrange it to put it back in the correct form. So this one, if you remember from what we wrote down on the first day of notes, from standard form, we can most easily find the y-intercept, because when we put 0 in for our x's, we end up with c. This constant right here is going to be how we find our y-intercept. All right, now to find the vertex from this point, from this form rather, and remember, the vertex is either your maximum or your minimum, and the equation that you're going to need, h equals -b over 2a. Okay, so let's put that to use. First of all, here we have a quadratic. And again, I know it's a quadratic because x squared is my highest term. What form is this? This one is going to be in standard form. Remember, when it's in vertex form, I see parentheses squared. When it's in intercept form or factored form, I see 2 sets of parentheses. And when there are no parentheses like this, it's in standard form. Okay, let's find the vertex. So first, to find the vertex, I'm going to use my formula, h equals -b over 2a. All right, let's substitute in. So b is the number that's in front of x, and in this case, the number that's in front of x is a -1. So be really careful when this one is a negative. I have a negative in my formula, and I also have a negative value for b, so I need both negatives there. 2 is in my formula. And then a, I see a is the one that's in front of the x squared, and a is going to be -1/2. Okay, so let's simplify this. In the numerator, negative times a negative is +1. +2 times -1/2 is -1. And 1 divided by -1 is -1. So I know that h is -1. H is the x value of my vertex. Well, if I want the y value that goes with it, if I want to find k, I have to substitute in to the original equation, and I'm going to use that -1 value that I found for x. So -1/2 times -1 squared minus -1. Again, be really careful with that minus and the negative, plus 6. Okay, so you can just type this directly in your calculator if you want to, and you're going to end up with 6.5. So there's my vertex, -1, 6.5. Okay, skip down here to D. We need to know if this is going to be our minimum value or our maximum value. So look, A is negative. Remember, when A is negative, that means the parabola opens down. So the vertex is going to be our maximum, -1, 6.5. Oh, my decimal didn't turn out very well. That's not a comma, that's a decimal. And my minimum value, well, there's not going to be a minimum because it's going down forever. Okay, now let's go back up to C, axis of symmetry. Be really careful with this. The axis of symmetry goes through the H, it goes through the X value of the vertex. But if you just write -1, you didn't write a line equation. The axis of symmetry is a line, so you always want to put X equals -1. Okay, let's put what we have so far on our graph. So go to the point -1, 6.5, which is up here, and put a dot for the vertex. And then going directly through there, we're going to put a vertical line. X equals is always a vertical line. And it's going to be dotted because remember, that's not actually part of our graph. That's just there to help us draw the graph. So that's what we have so far. Okay, let's see what else we can find. So x-intercept. All right, if you remember from what we've done before, to find the x-intercept, I put 0 in place of y. And now I'm going to solve this for x. Okay, so we haven't learned how to do this by hand yet. We're going to learn how to do this by hand in the next coming weeks. So what I need you to do is I need you to type this into your calculator for y1 and then find the x-intercepts like we practiced in class. Well, the calculator doesn't use the word intercepts. Think about the synonyms that we have for x-intercepts. Which one of those is the calculator going to use? The one you want to use to find the x-intercept is zeros. Remember, they're also called solutions or roots, but the word your calculator chooses to use is zeros. So when I do that, and I do the left bound and the right bound, and then I guess, I'm going to get two answers. X equals -4.6 and x equals +2.6. I rounded both of those to the tenths. So my x-intercepts, I'm going to write those like points. The x value is what I found on my calculator. The y value is what I substituted in to start with. All right, so there's my x-intercepts. And you can go ahead and put those on your graph. Here's -4.6. And over here is 2.6. And remember, we said they should be an equal distance away from the axis of symmetry because it cuts the graph right in half. So let's find out. 1, 2, 3, and then 0.6 more. And on this side, I have 1, 2, 3, and then 0.6 more. So that's a good indication that I did it right. I'm an equal distance on both sides of the axis of symmetry. Okay, now let's find the y-intercept. Remember the y-intercept, because it's on the y-axis, I know that the x value is 0. And this is also one of the things that we know is easiest to find from this particular form. Because everything that's on this part is always going to equal 0, and then 0 plus 6 is 6. So remember, we said that the y-intercept is that c value, and you can see that here. So my y-intercept is going to be the 0.06. The 6 right here is the c value when it's written in standard form. Let's put that on the graph as well. Okay, so if I have a point here that's 1 unit away from the axis of symmetry, I should have a point that's equally distant on the other side. So go ahead and put that point there as well. And now you're ready to connect the dots. Make sure it's a nice smooth curve. Make it look as much like a U up here as you can and not like a V. Okay, so from this, let's find our positive intervals. Okay, so remember, positive means above the x-axis. And I can see that this one is positive in this area. So the thing that I'm going to use to determine my intervals is my x-intercepts. That's where it crosses the x-axis from being positive to negative. So my x-intercept right here is -4.6. That's where my interval starts. And then it ends over here at positive 2.6. It's positive in between those two values. So my interval for positive is negative 4.6 up through positive 2.6. Remember, for your intervals, you always need a starting point and a stopping point. Okay, well, how about where this one is negative? If positive means above the x-axis, then negative must mean below the x-axis. So we're going to find the intervals where this one is below the x-axis. And we have two, here and here. Now remember, Desmos doesn't put arrows, so you need to go back and make sure yours has arrows. That's going to cause you problems with your intervals if you don't. Okay, so first this one on the left. All right, intervals always go from left to right using only my x values. Farthest to the left is going to be negative infinity, and it continues negative until it gets right there to that x-intercept. So negative 4.6, that same x-intercept that we had before. Then we're going to use our U symbol for union because I'm going to combine this interval with this interval over here. Again, left to right, so it starts right here and it goes on and on forever this way. So it starts at 2.6 and then it goes on and on forever. Okay, now think about this. Should we put negative infinity here or should we put positive infinity? Remember, we're focusing on x values. We're going to put positive infinity because it's moving to the right. I know that it's going down, but that's a y value. I want to think about the fact that it's going to the right, which is towards positive infinity, which is my x value that I want to base my interval on. Okay, now let's think about increasing and decreasing. So what does the word increasing mean? Increasing means that it's going up. So this one begins increasing over here. I had to erase my arrow, but it begins increasing over here, and it increases all the way up to the vertex. So this time I want to use that vertex value. And do you remember what the x value was of our vertex? It was -1. So when I do my increasing interval all the way to the left, up through -1, but not including -1, at actually -1, it's not increasing or decreasing, just pauses for a moment. And then decreasing means going down. That's going to be on this side, arrow on that end. So my decreasing interval is going to be -1. And again, should I put positive or negative infinity here? I'm going to put positive infinity because just like before, I want my intervals based on x values. And although that arrow is going down, it is also going to the right. Okay, let's look at end behavior. So for this one, as x approaches negative infinity, that means as I go to the left, I'm looking at this part of the graph. Which way is f of x going? Which way is y going? This is when I want to use that negative infinity because it's going down. And remember we said for parabolas, those are always going to match. If one of them is negative infinity, the other one is going to be negative infinity as well. They're always going to be the same. My domain, all right, all the way to the left, all the way to the right. Remember, domain is x values, and x values go from left to right. So this one is going to be from negative infinity to positive infinity, right? That arrow tells me forever left. That arrow tells me forever right. How about range? Range is the only time we're going to talk about y values. Everything else is based on x values. So for range, for your y values, the lowest that this one goes is negative infinity. Again, those arrows telling me it goes on and on forever down. And it's going to go up through this point right here. This y value from the vertex was 6.5, and that is going to be included. Our graph does actually reach the y value of 6.5.